Very good evening to one and all gathered here. Today we are going to continue the further the topic on design of machine elements. Here today we are going to see about design of springs in vehicle application. So what are the following main important key factors considered for a spring design? One is material selection, then stress analysis and fatigue life predictions. These are the main important key parameters to be considered. And the last one is manufacturing constraints. And this gives about a note on different types of spring classification: helical coil spring, leaf spring, and torsion spring. So what are the materials used for the spring fabrication process? So spring steel, non-ferrous alloys, and stainless steel. Each have distinct properties and features. Here we are going to see about what are the different types of stress analysis in spring design. So torsional shear stress, direct stress, and bending stress. And other design consideration like calculation of spring index, spring stiffness value, free length, solid length, and end conditions of the spring design. And finding out the fatigue strength of the spring that can able to withstand the repeated cyclic load without failure. The next method is Soderberg line method. This is normally used for considering fluctuating load to estimate both fatigue and yield strength. The manufacturing methods of the spring design: cold working method, heat treatment, and surface finish process. Now let us go through this problem. So consider a helical coil spring which has a maximum load this much amount Newton, 1000 Newton, for a deflection of 25 mm. Considering a spring index as 5, the maximum permissible shear stress is given to be 420 megapascal. The modulus of rigidity is 84 Newton per mm square. They have given the various the elastic constant and the allowable shear stress value for the spring design, deflection, and the load. So calculate the mean coil diameter of the spring and the wire diameter of the spring. From that, we can able to find out what is the outer diameter of the spring coil. These are the detailed workings that are given using formulation method. With the help of the maximum shear stress formula, we can find out the wire diameter, spring wire diameter. Then finally, we can calculate the mean coil diameter using the spring index value C. Then at last, outer diameter of the spring coil. The next one, number of windings present in the coil. So with the help of the deflection equation, find out the number of turnings. Then apply the end condition of the spring. It is assumed to be square and perfectly grounded flat, both the ends. So use this equation and find out the total number of turns in the spring coil. Then next one, calculate the free length of the spring. And lastly, find out the pitch of the coil. So this is the procedure applied for performing the design calculation for the helical compression spring. So with this information, I conclude that the design of spring, which gives a clear view about the formal, well-designed procedure for a spring model in order to possess high sufficient strength to withstand any type of applied dead load which is acting on the structure. Using that, we can able to find out the expected load deflection characteristics by considering the following factors like material properties, dimensions, and potential stress, and so on. So the spring design will give you how reliable the material to be selected. Accordingly, it will serve its function or purpose for the intended application. So I thank once again. We will meet in the last lecture, that is in the next meeting, design of bearing elements. So with that, we will wind up the short course, design of machine elements. Thank you once again.